9-volt battery, little thing on your radio or something like that, that's 9 volts. Your wall socket where you plug in your TV or something like that, that's 230 volts. The big transformer in the corner there does up to 330,000 volts, so that's pretty high voltage. That's higher than the biggest power lines in New Zealand that go across the countryside on the big metal towers. Yep. The big stack of power up there in the middle of the room, that does up to 1.4 million volts. So that's sort of like a lightning generator almost by itself. It doesn't have as much power behind it as what say a lightning does. A lightning really sort of blowing things apart, so it has a lot of sort of punch or power behind it. Anyway, we're going to show you these two big spheres up here. Use them for sort of like, some calibration and stuff. It's like, how big there's a real whole set of maths that goes into sort of like, figuring at what stage does air break down like lightning. When lightning strikes, the air molecules rip apart, and then something electricity conducts. So what we're going to do is the same here. We're going to push two spheres closer and closer together when there's a high voltage across it, and then see what happens. Alright, so if you switch it towards decrease here, the bottom sphere will start rising up. Alright, here's how it allows to operate the voltage. Let's do that. Okay, so let's turn the power off. And turn the key. Alright, it goes on. Alright, stop the sphere for a moment. This in the centre, cool. Alright, so what we're going to do now is press on. Right, we now have power. This panel here connects to the quick box over on the far corner there, which then connects to the transformer, which I'll then hook up to the top sphere, which has a big insulator that's insulated from the roof so the voltage doesn't jump to the roof. So what we're going to do now is press raise until we get up to 50. No, that's a different sort. This thing here is exactly clever as well. It's two metal poles sticking up in the air. One is connected to high voltage via a red cable connected to the big transformer in the corner there via a big water resistor before it flowing through that light zigzag around there. And it comes down there, and the other side is connected to earth or ground. So there's a huge voltage. We're going to go up to about 110,000 volts again. Huge voltage here. And of course, we're going to get the same sort of spark between the two spheres. We're going to get the same spark here. Okay? But what's going to be interesting is what happens after it sparks. So you guys may have seen this before on videos, YouTube, something like that. Here's the question. Why do we use a ball wooden ladder in this laboratory? What is that? Yeah, basically, if it was to touch something, it's easier. So it's just a safe thing. We could use it for that, but that runs the risk of accident touch or something that it should. So it looks good. Probably more about 2,000 years ago. It's been used ever since. It's a pretty good day. It's been here probably before I was born. Right. So we need another volunteer to raise the volume again. Someone has another. Right. So. Sometimes you like start and buzzing noises after rain, like voltage power ones. That's basically the little water outlets sparking electricity away to the air. It's more noisy when there's water hanging on the light because it's not still around. Right, there we go. 80,000 volts. 17. 80,000 volts.
Alright, so you know you get an ice cube and you heat it up, what happens? Yeah, it turns to water, it's a liquid, right? What happens when you heat up water? Yeah, it turns to a gas, right? But what happens when you heat up gas? It turns to the fourth state of matter, which you guys don't learn in school, but it is there, and you just saw that, and that's plasma. Okay? Now, for the same theory, you can actually burn anything with high voltage. Alright, so in this case, we're going to burn some wood. See how it goes. Now, you guys have been taught that water and electricity don't mix. I reckon water and electricity mix really well. You have the lights on? So this is exactly how lightning behaves. Okay? Basically, if you imagine that top electrode as a cloud, it's usually really charged up. Right? What happens is basically a whole bunch of little step leaders, they call them, start working their way down towards the ground. They're trying to find the other electrode. Right? Of course, this is the rain that's accompanied with it. They make a whole bunch of really cool little patterns. Right? So they just keep creeping, trying to find their way through. Burning little parts.
This camera here is a heat camera. It shows the heat that's going on. You can see the heat on the screen there. That's going up to about, on the scale there, 140 degrees. You can see it's like when you pointed at a person, for instance, you can see the heat of the person.
Oh.
So, someone want to grab the camera if you want and have a look. Just hold it. There's a big handle grip underneath it. Cool.
People are just used to neutral being in there.
Cool, and now you'll see.
Too much voltage. How many volts?
Oh, they can only go up to about 7,000.
7,000 volts.
Now, you see where it's just going to touch the other end.
Still a lot more than a 9-volt battery.
Yeah, it is, yeah. You see all those little patterns? That's exactly the same thing lightning does on its way to the grid. You just can't see it because it just sort of slows it down.
So high voltage does have sort of, you know, a lot of art in it as well.
Yeah.
And create some interesting sort of artworks.
So if anyone wants to take this piece home, I'll take it with you. I've even got some pieces there I made just before. Okay,
You've clearly done this hundreds of times before. Is this part of the syllabus? Yeah, it's not. I can just pick it up. You don't mind if I choose that one? That one.
Hey, what are you trying to say about my cooking ability? Very good.